Hi everyone, I'm Jacky. I'm here to present my research about the environmental impact of wind turbine blades. As you may know, wind energy is one of the most promising and fast developed renewable energy in the world. The installed capacity increased 20 times in the past 2 decades. It currently supplies more than 10% of electricity in Europe. A typical wind turbine has 3 major components. It has the tower to support the structure made with steel. The nacelle has the converter and electricity generator brake control system inside with steel, aluminum, rubber, and other rare earth elements. The nacelle frame is made with glass fiber reinforced composite materials. And the blade is used to capture the wind, which is quite large. Currently, the mainstream one is between 50 to 80 meters. It's made with glass or carbon fiber reinforced composite. Compared to other conventional materials like aluminum or steel, in this system, composite materials are relatively new. And currently, there's no well-established recycling route for them, especially for glass fiber reinforced materials. It could cause some environmental problems. The design lifetimes for wind turbine blades is 20 years because of the high fatigue limit. They may need to be decommissioned in a short time. The first batch of commercial wind farm is already need to be decommissioned in next 2 years in Europe. So for these problems, I have proposed 3 sub-research questions. So what is the size of this problem? What is the impact of this problem to environment? And how can we solve them? Because of the time limit, today I want to answer the second, what is the environmental impact of this? In the first part of my research, I found the number of the blade weights will be more than 2 million tons per year in 2050. And as the wind turbine is fast increase, so this number will get more and more. How to answer the question about environmental impact? We start from the bill of materials of the blade from 3 blade manufacturers. We analyze more than 20 blade models. When we get the bill of materials, we classify them into the material category, say what is the major materials, what is the supporting materials, what is the manufacturing consumables. And we found the matched ecological data from the database. We set different scenarios, like different scenarios of manufacturer waste level, different scenarios about transportation, different operation maintenance requirement. And we calculate them together to get the life cycle environmental impact of the blades. So the first step, from the bill of materials, we can find by weight the reinforcement materials like glass fiber or carbon fiber are the major one by weight, and followed by resins and adhesives as the matrix materials. The other supporting materials proportion is quite small in blade. And we found the matched ecological data from database. As you can see by the unit the impact, carbon fiber is the highest, followed by aluminum, and the resin system is not low as well. Then we used the materials by weight times the unit of environmental impact. I just show the energy consumption of it. The picture changes. So the major energy consumption during manufacture blade is from the resin system, and then followed by the reinforcement materials. So it shows like the resin and the reinforcement materials have the biggest potential to reduce the environmental impact in the future. And for the life cycle environmental impact, we calculate that from the manufacture stage, transportation stage, operation maintenance, and end of life. For the transportation stage, we have set different transportation method, which is typically used in the blade transportation, like medium-sized truck, large-sized truck, or sea freight, and some cases of transportation, like from inland China to the seaside, or from UK made in Isle of Wight, Denmark. And we also set the boundary with the operation and maintenance limit requirement for the blade. They vary between wind farm to wind farm, vary from the turbine model to model. And we put them together, we can get a result. It shows the manufacture stage dominates the environmental impact of the turbine blades. It has more than 95%. The transportation and the wind operation and maintenance part is quite small. And when we compare the models, even for the same class of turbine, they have varies a lot in terms of the consumptions. Because the early model is kind of installed in the high wind region, so they are relatively shorter. The new one is longer, so they use more materials. Previous study, they classify them by the rated power, but actually it's not the truth. We should classify them case by case. And it also shows, although these two kind of blades generate the same amount of power, but if we use carbon fiber as the major materials in the spar cap, it's hugely increased the environmental impact. And we found the manufacturers, they are the top three, but they varies the in-house waste level. If we can do something that, it also can save some reduce the impact. And those are the conclusions. As I said, it's like the blade varies in the same class, is up to 34%. The carbon fiber reinforced blades have more than about 50% more impact compared to the glass fiber blade. And if we have more and more application of the carbon fiber in the blade, there will be huge increase in the overall result. And the manufacturing waste varies between manufacturers. If we can set some agreement in the industry that could save some energy. And the focus should be on the manufacture stage, as the other part of the life cycle is quite low. And because the manufacturer part is dominant, in the disposal part, there are some potentials to be improved in the future. Yeah, thank you.